All right. So by virtue of this property, what is going to happen? You will be able to even reduce your computation. If you know the first few values, suppose it's an 8-point DFT, instead of the first instead of computing the entire DFT, you can use this property and you can reduce your computations. That is, you can always keep very few calculations you will do. So just imagine, if you're able to reduce, suppose 8-point DFT, if you can just do the calculation for just 4 points, okay, how many complex multiplications and additions will happen? You can just imagine, you just recall, you're going to implement this on a program is going to be dumped on a hardware. Just think in that fashion. So what is going to happen? So many computations will be very cumbersome to you. It's not going to be that easy to do so many calculations. It is time consuming, it heats up the device, it is, consumes lot of power, lot of disadvantages. So if you're able to further reduce this or exploit some symmetry in your output or in your answer, what is going to happen? That's going to be great. Okay, you can reduce the computation, you can that thereby you can improve the speed of calculation, you can reduce the heating up of the device. All these advantages you have got it. So this is a very important property, wherein you will, in future, it's going to help you to reduce lot of calculations. You will exploit this property to do that. So let us see one by one what are these. So symmetry means for a real valued sequence. Okay, real valued means you have real numbers, you have no imaginary terms. That means if you take a time domain signal which is real valued, you don't have imaginary terms. That's the meaning. Okay, is real, then its DFT is given by, let me, if you want, I can increase this further. I hope it's visible. Yeah. So the DFT of that is going to be what? X of k. X of n is your signal, X of k is your DFT. Okay. So you want to say that your X of k is equal to X star of n minus k. That means you take the conjugate of this at n minus k, it is same. So there is a symmetry you want to prove. So how do I do this? The important thing here is X of n is your real sequence. Maybe when you see a problem, you will understand much better. Okay, but let us first try to figure out what is this. So first thing, as usual, first write your DFT equation. X of k is equal to 0 to n minus 1 x of n wn power nk. Okay, this equation all of you are familiar with, no problem. Okay, now the thing is, you want the star. Star refers to conjugate. Okay, so X star of k means what? What is the meaning of this? What is the meaning of this? Yes, X of n plus k. So I can show you. Suppose X of k. I have a sequence like this. This is an example. Okay, what is symmetry? I need to hold like this, right? What happened? I'm sorry. Okay, when I say X of k, okay, say I will take a number 2, 2 minus 2j, 0, 2 plus 2j. Okay, something like this. Or you can even take any of the problems that you have already solved. Okay, any one of the problem let me take so that you can understand. I can show you my notes where I have a example. Hmm. So basically conjugate means, suppose I have a minus j term, the conjugate of that is going to be a plus term. Is it not? All of you know this? All of you know what is conjugate, right? No? So there's a difference between your conjugate and the negative of the term. Conjugate means basically uh, in a particular DFT, always you should remember, in case of your DFT, if it is a real valued sequence, your input is a real valued sequence, then in the output there will be something called as conjugate symmetry. You take any problem for that matter. Okay, any problem that you have seen earlier, you just have a look. Say for example, look at this problem. This was one problem that we solved for linearity property. Is it not? You had here, you look here, you had here minus, I hope all of you had got this answer, right? So this is a 4-point DFT. So if you don't bother about the imaginary terms, look at the real term. Look at the real term. Remember this, for linearity I gave you a 4-point DFT problem. See, this is it. So 3.414. See, only two imaginary terms are there. The x of 0, x of 1, x of 2, x of 3. So x of 1 and x of 3, if you observe, they are symmetric. Only thing is, this is minus j, this is plus j. This is what I was trying to explain to you. Got it? So this is what is mentioned over here. This is what is mentioned over here. That's what x of, no. What I'm telling is x of n is real. The answer x of n is real only, right? See, in that problem, x of n was real, but the answer, the x of k, the DFT is conjugate. You have a complex term in the DFT, right? So we are speaking about the conjugate of the answer. I'm not talking about real got we have got real values, but for the real value you don't have a conjugate, is it not? For real values you don't have conjugate, but for distinct terms, whatever imaginary terms are there, you have conjugate terms as well, is it not? That is what we are meaning. It's not about real terms. That is what in the next step you will get to know that. I will show you. See, the earlier problems also, whatever we saw, whatever we have done, say look at this. This was cos n pi by 4, sin n pi by 4 was one of the problems that we did, right? This was one problem. Cos of n pi by 4, what were the values? It was 0, 1 by root 2, 0, minus 1 by root 2. These are all real terms only, right? 0, 1 by root 2, 1 plus 1 by root 2. Are there any imaginary terms in this? Are there any imaginary terms in this? Tell me. No, right? It's not there. So, what I am telling is the DFT of this, see 1 minus 1.414j, 1 plus 1.414j. See this 2.414 minus 1. Here in the second DFT, there is no imaginary term. Here there is imaginary term. So, what I am speaking about is when there is an imaginary or when there is a imaginary term in the answer, then what happens? Getting? So, the sequence that you have is real. This is a real valued sequence, right? See these numbers. 1 by root 2 means it is 0.707. So it's a p by q form, it's a real sequence. But the DFT is imaginary in nature. So if you take the conjugate of this, suppose I write this as x1 or x1 star of n. Okay, x1 star of n is same as x1 of n. There is no conjugate for real terms. How can you write conjugate terms? You can write like this. Say any number, say for example 2. I can write it as 2 plus 0j. Okay, I can write 3. I can write it as 3 plus 0j, or I can write it as 3 minus 0j also. Is there a conjugate? This is conjugate of this, but it is same, right? So for real sequence, for any real sequence, I can say that x of n is equal to x star of n. Can I say this? Yes or no? Getting? But for imaginary terms, whenever imaginary term is present, can you do that? Whenever imaginary term is present, you cannot do that. So what is told here is x of k is equal to x star of n minus k. Got it? This is the first thing that is mentioned. So let's have a look. Okay, just have a look here. So it is told x of k is equal to x star of n minus k. X of k is given by this. Taking the conjugate on both the sides, what happens? X star of k is same as x star of n wn power minus nk. So can I say that, suppose I write wn power k. You know this is nothing but e power minus j 2 pi by n into k, which is nothing but cos 2 pi by n into k minus j sine 2 pi by n into k, right? You know this? All of you know this, right? Okay. Now, what is the conjugate? Conjugate of this will be what? Okay. Cos 2 pi by n into k plus j sine 2 pi by n into k. All of you are aware of this? This is okay to you? Imaginary term you have changed. So, this is nothing but what? This is nothing but e power plus j 2 pi by n into k. But e power plus j 2 pi by n into k is what? This is wn power minus k. So can I say the conjugate of wn power k is wn power minus k? That's it. So having known this, we will look at this one expression. Now have a look at this. So x of k you have written, x star of k is the conjugate. On both the sides you take the conjugate. So this x of n becomes x star of n. wn power k into n becomes wn power minus k into n. Okay, since x of n is real, x of n is equal to x star of n. What is the meaning of this? X of n is real means this one, this thing. 3 plus 0j or 3 minus 0j, it's the same. So you can always say if it is a real sequence, it is x of n equal to x star of n. Got it, all of you? Okay. So next, after this, now we are going to split it. You have x of n wn power minus k into n. One extra thing that I'm going to do is, you have to prove here x of n minus k term has to come. So how can you do it? You know wn power n is nothing but 1, isn't it? So what I'll do is, I'll multiply, this is the extra thing step that you're taking. Wn power capital N into small n, you're going to multiply with this, so that you can obtain wn power n minus k term over here. Is this and this same? Have a look. It is same, right? Does it make any difference? So you are going to write it as x of n wn power n minus k into n. So what happened on the LHS, you had x star of k. This is x of n wn power n minus k into n. So you can say that if you look at this expression on the RHS, is it not the DFT of x of n minus k, because instead of k you are having n minus k. Are you getting what I am telling? The key step over here is this: Wn power n into n, you need to multiply. Why I am doing this? Observe carefully, because you have to prove that x of n minus k is equal to star, x star of n minus k is equal to x of k. So you have to somehow get your n minus k term. So for that, what you can do, you have only minus k into n, you will multiply Wn power n into n. Okay, got it? Got it, everyone? Okay. So the above equation conveys that the DFT of a real sequence possesses something called as conjugate symmetry about the midpoint. So that means at suppose n equal to 7, the midpoint would be what? 0 to 6 you will take. So you don't have a mid value for that. So between 3 and 4 you draw a line. You can see all the alternate samples. You take any DFT example, this property is well proved. Suppose it n is even, you have a value. A capital N is 8, then the midpoint is 4. That means third and fifth value will be conjugate symmetric. Second and sixth value will be conjugate symmetric. First and seventh value will be conjugate symmetric. So just imagine, if you are just able to do half the calculations for any such lengthy DFTs, that would be sufficient for you. You don't have to, you don't have to do further anything. Got it? Just calculate only the half set of values, the rest values, you can just write it as your conjugate symmetry value. Got this, all of you? Okay. This one. All of you have understood, right? This is your symmetry property. Above. Okay. All of you go through it if you have any doubts. Yeah, tell me. Yeah. Huh. No. I will explain to you why it is like that. I will tell you why it is like that. Don't worry. Just a minute. Give me a minute. So what I am telling is, what is the value of W? Okay. Wn power n is what? Is nothing but 1. Isn't it? So whether you multiply this one on LHS or RHS, what is the difference does it make? So in that step, in that particular thing, what is the thing given? What is it mentioned? See, it is Wn power minus k into n. That is your normal DFT equation. Is it not? Normal DFT equation, Wn power minus n into k. See, you have x of k is equal to summation n equal to 0 to n minus 1 x of n Wn power nk. Because you took conjugate, it is minus n into k. Okay. Now what you want, as I told you, you want to prove x of k is equal to x star of n minus k. This is what you want to prove. So you mean to say that at n minus kth position, that means from the center, if you take left and right, the different values that you have are conjugate symmetric. So you want this n minus k term. That is the reason you are going to multiply Wn power capital N into n. So since the index small n and small n is there, you can aram say remove the small n and write capital N minus k. Why I am not multiplying the same on the LHS is that, okay, I am not going to multiply it on the LHS because this term is nothing but equal to 1. So whether I multiply 1 or not, it doesn't make a difference, right? My aim is what? On LHS I want to keep x of k, on RHS I want to obtain n minus k term. Is it not? Understanding? So this is nothing but 1. It makes no difference to me. So in the next step what I'll do, I'll write it as the x of n, wn power, n minus k, you took it out, n is there. That's it. 0 to n minus 1, this. So this looks like, you compare it with your original x of n equation. X of n followed by a w term. Instead of wn power k, you are having wn power n minus k. So what is this? This is nothing but DFT of, or you could rather say this is nothing but the DFT of the sequence x of n such that it is x of n minus k. Got this? This is what we were trying to prove. So I don't have to multiply on LHS and RHS because this term is equal to 1. I am going to adjust the term in such a way that I'll get n minus k in my RHS. Got this? Anuj? Anuj was the one asking me, right? Yeah. Wn power n is 1, right? How is it? E power minus j 2 pi by n into n is what? This n and n goes, this is nothing but e power minus j 2 pi. Is it not? E power minus j 2 pi is nothing but 1. Yeah, yeah. Yeah, that is 1. That is 1. That is 1. I have multiplied 1. Instead of 1, I am writing it as wn power n. That's all. Okay. So let's go back. Okay. So for a real sequence, x star of k is nothing but x of n minus k. You have proved this. So if you look at a problem, compute the 5-point DFT of the sequence. There's a DFT equation given. 5-point DFT because you need to calculate W5. So this is what I was telling you. First calculate the twiddle factor values and keep. Okay. Anyway, this is there. You can write down later from the classroom. Go to Google Classroom and take this properties page. You can write down this. It will take time for you to sit and calculate this. Okay. 5-point DFT. So we know that the DFT is given by this one. What you need to prove, you have to check the symmetry property. X of k you write down first. You got the expression for x of k. After you do that, once you solve it, normally whatever you were doing, write it down and show the symmetry property. So the answers you will get for this, I'm more interested to show you the answer because right now you know already how to prove the DFT. So you just observe here, in this case, you are having full of imaginary terms. So x of 0, x of 1, 2, 3, 4. So n is equal to 5. So roughly at this n by 2 is 2.5. So across the midpoint, you're going to have the symmetry. That means second and third values are conjugate symmetric. 0.5 plus j 1.538. See this 0.5 minus j 1.538. Is it not? Then you have 0.5 plus j 0.364. 0.5 minus j 0.364. First and fourth value is conjugate symmetric. How to see this? 2 plus 3 is 5. 1 plus 4 is 5. The index values I'm telling. So ideally, for any problem you take, this conjugate symmetry is proved. So what you can say here, x star of k is equal to x of n minus k, can you say? Just write and see. Suppose I take 1, x star of 1. That means conjugate of 1 is equal to x of 4. Is it correct? Conjugate of x of 1 is what? 0.5 plus j 0.364 you have. Conjugate of this would be 0.5 minus j 0.364. Conjugate of this, is it equal to x of 4? Obviously. See x of 4 and x of 1. Take the conjugate of x of 1. Is it same as x of 4? Is this relation proved? All of you carefully observe. Similarly, take x of 2, 0.5 plus j 1.538. What is the conjugate of this? 0.5 minus j 1.538. So conjugate of x of 2, is it same as x of 3? Obviously it is same. Got it? I hope all of you have understood. Okay, please go and solve this. Same thing, whatever you were doing earlier, first find out the twiddle factor values, write it and keep first. Okay, n into k values. Then you put it in your normal DFT equation, get your x of k expression, go on giving values, k varying from 0 to 4 because it is capital N equal to 5. Solve this, don't just leave it like that. Solve this problem and check whether you're getting this answer. Anyway, already I have posted this in the classroom. So similarly, you will get other, say in this problem, see this is a very interesting problem. The first 5 points of an 8-point DFT of a real valued sequence is given. So they have given in certain problems, right? You may not even have to calculate anything. Directly, you will just have to write down the answer directly. I mean, use some property and write it. So whenever properties problems comes, usually it will be very easy for you to solve things. Okay. So look at this. You have first 5 points of an 8-point DFT. So how will you write? Using symmetry property, you need to first write down the rest of the points. So first 5 points, if you have the rest points, you can write by using the conjugate property. Do you have to calculate IDFT and then calculate DFT of this? Not necessary. Okay, you can't do it also. So x of 8, you know x of k is equal to x star of n minus k. Apply this, x star of 8 minus k. So go on giving, you have values till 0, 1, 2, 3 and 4. So x of 5 is nothing but x star of 8 minus 5. So x of 3 you take conjugate of that 0, 1, 2, 3. This is x of 3. Conjugate of this is nothing but your x of 5. Similarly, conjugate, next term conjugate is nothing but this. The next term conjugate is this. The last term conjugate is this one. Got it? So you will get all your values using this. Okay, so you can similarly you can do the rest of the proofs are there. Have a look at all these things, you will understand. It's a very simple property. Okay, next thing is circular folding. Circular folding is similar to negative. That means you mirror the signal, time reversal you do, right? Same thing, similar to that. Because it is a circularly symmetric signal, that is, it's a periodic signal, you can say that it is circular folding. So x of minus n you're going to calculate. So in that case, what happens to the DFT? That is what we are going to see. So I hope the rest of the things you people will go through. Rest 2 problems that is given there, please solve it. There's one simple proof also, just very similar, not proof actually, it's a standard problem. Just have a look at it. Have a look. If you have any issues, you can let me know in the next class. Okay. So we'll see this one now. So x of n, suppose it is 1, 2, 3, 4. X of minus n will be what? How will you write x of minus n? How will you write? Do you remember this? Even in your signals and systems, you would have done this. No problem, even if you don't remember. So just imagine at n equal to 0, you had this. You had 1, 2, 3, 4. N equal to 0, 1, 2, 3. X of minus n means what? At n equal to minus 1, what I should have? Minus 2, what I should have? Minus 3, what I should have? Minus 4, what I should have? Okay. So what will be those values? What will be those values? Since it's a symmetric thing, same thing will be repeated over here. So you want to reverse the signal, you want to reverse the time value. So whatever is there at the last, you will write it first. It is total reversal. So the last sequence you write it, next the next value, next value, next value and so on. N equal to 0 is just 1. because the periodic extension of this is there, right? You have your 1, 2, 3, 4. Right now what happened, because you reversed the time, the sequence itself got reversed. Okay, that is a periodic extension. So let us take few samples from this. Okay, and what I'm going to prove is there is symmetry even in this. So yesterday's class I was telling you there is something called as even symmetry and odd symmetry. If x of n is equal to x of minus n, then the sequence is said to be even symmetric. Okay, if x of n is equal to minus of x of minus n, then it is odd symmetry. Always if the negative term is present, it is odd symmetry. So for a real valued sequence, just 1, 2, 3, 4 only you consider, we will see how this is executed or how we'll use this property. So you consider circular shift of this sequence of any sequence. For example, this 1, 2, 3, 4 we'll consider. It is equivalent to linear shift of the periodic extension. This I have shown you in the earlier classes also. So if you want to do circular shift, you can write the sequence 4, 5 periodic extensions you can write, and you can, by looking at that, you can say what you're going to do. You remember this? Previous classes also we have seen this. So you can write it like this. Suppose this is x of n, you can write it over a circle 1, 2, 3, 4. That is x of 0, x of 1, x of 2, x of 3. Suppose it is x of minus n you want to write. How will you write it? Have the same circle, you will read it, instead of reading it like this, you read it like this. That is, if you are reading it clockwise, if you are reading it anti-clockwise. So x of n, if you are reading it anti-clockwise, same x of n you read it clockwise, then it will be x of minus n. The best way to write it. Getting? Or else one shortcut that I told you is x of n and x of minus n. How will you write it? Minus n, nothing but last value you write it first. All the values you write in the reverse order, you write it here. 4, 3, 2 you write it. 1 you write last. Or if you're not able to understand that, you draw a circle. Usually they'll follow. Even for circular convolution we will see this. This is how we will write x of n and x of minus n. So this is nothing but your circular folding of a signal. Just remember this, because we'll be using this also for we will find the DFT of circularly folded signals also. Okay. So same thing, if this is a circularly folded signal, how do you find? It's also called as time reversal. So when you find the DFT of the signal, x of minus n is same as x of capital N minus n. Okay. So the DFT of this, how I can write this expression? This is because the signal is periodic in nature. Because it's periodic, any n minus n value, whether it is this or this or this, it is the same. Whether I consider this small one or this small one or this small one, all this is same. Are you getting what I'm telling? Since it's a periodic extension, I can write x of minus n is equal to x of capital N minus n. For even symmetry, it is x of n equal to x of minus n. For odd symmetry, x of n is equal to x of minus n. Just remember this. We will be using this even in your DFT. We will prove it. Okay. So DFT of x of n minus n is same as x of minus k, which is also same as x of n minus k. Okay. So one by one we will look at this, how we will be solving this time reversal of a sequence. Okay. So you know that as usual, first thing you will be taking your x of k, your DFT equation. DFT is equal to n equal to 0 to n minus 1 x of n wn power n into k. Lower limit is there, upper limit is there. We are going to alter this by some other term, small m. Why am I going to do this substitution? That is because I want to introduce, if you just look at the last, I want to prove x of minus k I want, x of minus n I want, x of n minus n I want, n minus k I want. So if I introduce another dummy variable, it will be easy for me to do the calculation. So this is one. If you ask me, ma'am, suddenly why are you introducing another term? Why are you changing the limit? Because I want to consider the periodic extension and I want to introduce, see, I want these terms in the question. Whatever is there, you look at this expression. I want all these terms to be present. Okay, I want all these terms to be present. So I want n minus n, I want n minus k, capital N minus k and capital N minus n. I want x of minus k and I will consider x of minus n. All you know is given x of n is a real sequence, then DFT of x of n is given by x of k. What is the DFT of x of minus n? What is x of minus n? You just now you saw. X of minus n is nothing but the time reversed sequence. Got it, all of you? Please concentrate and try to understand. So x of n minus n term you want, n minus k you want. So what you're going to do is substitute instead of small n minus some m value. Now according to this, substitute the limits. When small n equal to 0, what happens to this? Capital N is equal to m. This is the lower limit. Upper limit you will get when n minus 1. Once small n is capital N minus 1 is equal to n minus m. You substitute, you will get m equal to 1. So the limit becomes small m is equal to capital N to 1, x of n minus m, w n par k into n minus m. So even if I have changed the limits, what was my goal? I wanted one n minus m term inside. Okay, because it is periodic, I want to introduce this term so that in the answer I'll be able to get n minus n term, n minus k term. Okay, that is the idea with which you should go forward. Okay, so this is there. Now you observe the limit, but I'm always comfortable with having 0 to n minus 1 so that I can do the summation. 0 to n minus 1, see the limits you can always interchange. This is capital N to 1. Capital N to 1, how many values are there? Okay, HOD's sir's class is there next. Okay. So you can continue in my this same link itself. Just give me a moment. All of you will use the same link. Okay. For your next class also, you can use the same link itself. I will send the same link to sir. So all of you don't go off for the next class. You don't go out. Okay. Yes. Yeah, sure. Who is that? Vikas. Yeah. Okay, Vikas. No problem. Yeah. Sure. Yeah. So just have a look at this. This is capital N to 1, 0 to n minus 1. Okay. So you change the limit from, instead of writing from 1 to n, you can take from 0 to n minus 1. The number of samples is the same. 1 to n you have n samples, 0 to n minus 1 also you have same number of samples. So now if you look what happens to this, wn par k into n will go. Okay, wn par minus k into m also. You open this bracket, this will remain. So what happens? Wn par k into n, you know wn power n, if it is there, it is nothing but 1. You cancel it and you keep this term. Now why am I very interested to keep this like this? Since m is nothing but a dummy variable, I can change m to n. This was my goal. To obtain this is why I introduced n minus m. because I want to say n is equal to n minus n, right? You want to have this relation. So n minus m you put, and once you are done with that, you can easily, if you observe this term now, n and n term got cancelled. All you're left with is capital N minus m minus m. So this m becomes small m becomes small n, and that is what happens like this. You can change it. This is nothing but, what is this? Carefully you look, n minus n. This is same as, instead of n value, you want to actually write the DFT of x of n minus n in RHS. So for that, there is one small hurdle. You should have positive term here. So how do I go about changing it? You can always write, replace k by n minus k. In the earlier equation we have seen, earlier case, because wn power n is 1. So instead of k, I can easily replace it with capital N minus k. Okay, again you open the brackets, you write it like this. I achieved my goal of keeping the positive twiddle factor, so that I can write this RHS as the DFT of x of capital N minus n. LHS, you have x of n minus k. You know x of n minus k is x of minus k. It is the same thing. So your LHS and RHS you have got. So basic idea here is, what you have to prove, you need to carefully look at. You have to prove this relation, n minus n term you want, n minus k term you want. So how you can introduce it, you must wisely think. Little you'll be playing around with the limits and all those things. Got it? Got it, all of you? You're just playing around with the limits and all that, so that this entire relation you can prove it in one go. Alright, so please have a look at this, all of you. Have a look at this one and try to understand how this is done. Time reversal property, and simple one problem is there. Maybe you see the problem and again you go through the derivation. You write it step by step. You will understand. Along with your homework, please include this also. This derivation and those two problems that I have asked you to do earlier. That is your circular frequency shift, folding. Some two more extra problems are there which I have not done. I have told you how to do it. Those problems also you solve it. Okay, I want all those questions to be done. Whoever has noted it down, probably Shiva Shankar or others, I mean, of course, only few of you speak in the class. The rest of you who have written it, please help out your friends and tell them what all are the homeworks. You just post it in the stream today itself, if possible after the class. Just after, I mean, whenever you're getting break. Next you have HOD sir's class. So please post it there. All right. Are you getting, all of you? And I want by next 6th of next month, all of you should have submitted the homework. More of, in the homework stream, I will post more of assignment questions or more of homework problems for you to solve it. Okay, so that it will be helpful to you solve more problems. Then maybe this one we can, if we have 2 more minutes, sir is not joined, 2 more minutes are there, I can just explain to you how, for a simple problem, how this property can be proved. So compute the 4-point DFT of the sequence. Also find y of k, it is told. Okay, example for this. So consider your y of n is equal to x of minus n. X of n is there. Take x of minus n. What is x of minus n in this problem? This is 1, 2, 1, 0. It will be 0, 1, 2, 1. That is your x of minus n. So find the DFT of that. DFT of this also you find. This will be your x of k. So y of n is equal to x of minus n. What is your reversing the DFT? After getting this DFT, what you are going to do? Reverse the answer. Y of k is x of minus k. So prove your LHS and RHS is equal. Okay, look at this. This is what you got. 4 minus 2j, 0, 2j you got. So x of k is that. X of minus k is 4 plus 2j, 0 minus 2j. So x of minus n is what? You will have 1, sorry, 0, 1, 2, 1. That will be your x of minus n. So take the DFT of that, that will be same as x of minus k. Got it? So you prove this property. This all intermediate steps are not written here. You have to do it. You have to write it. You understood what I told, right? You prove this property x of minus k is nothing but DFT of x of minus n. X of minus n, how to get it? You got it. Is it not? You got it or not? I'll show you or else. X of n, just a minute. X of n is 1, 2, 1, 0. So if you are comfortable writing in the circle, okay, okay. I'll show you here. What happened to this? Are you getting this? Oh my, something happened to this. Okay, so you see here, this is the question given to you. X of n is 1, 2, 1, 0. Okay, okay, let me write it again. I wrote it ulta. So on a circle, how will you represent it? 1, 2, 1, 0. I wrote it anti-clockwise. This is x of n. X of minus n, how will I write? You read it clockwise. This is your x of 0. So this is nothing but 1, 0, 1, 2. Okay, you take the DFT of this. You take the DFT of this. X of n you have. Take the DFT. You will get x of minus k. X of plus k, sorry, x of k. This answer, you reverse it. Reverse the answer. You will get x of minus k. Right? So once you get x of minus k, then from this x of minus n you have, DFT of that you take, prove that this answer and this answer is the same. Okay, this is what I want you to do. So tomorrow I will solve it. I will also solve it, and this page I will post it in today's heading. I will post this also. Okay, meanwhile I want you all to try it. Okay, fine then. Thank you. Let me download your attendance. Yeah, you can please stop. I mean, please, continue. Sir will join your next class. For next class.